So to finish our notes for today, to solve the right triangle, what we're really trying to do is find all of the missing angle measures and all of the missing side lengths. But in order to do this, we either need to know two of the sides of the triangle or one side and one of the measures of an acute angle. So in other words, we really need two pieces of information to help us be able to solve. So with that, we're going to introduce now a concept called inverse trigonometry. So inverse trig is going to be used to find an angle measure. So up to this point, we've used sine, cosine, and tangent to find a missing side length. So now we're going to use inverse trig functions, or inverse sine, inverse cosine, and inverse tangent to solve for a missing angle. But our process in the beginning is going to look very similar to what we've done so far. So for example, if they ask us to calculate the measure of angle A, we're going to place our eye, or our viewing point, at A. We're going to label what information we currently have. So I currently have the opposite and the adjacent. And then I'm going to think back to my phrase SOHCAHTOA and determine which trig function I need. So since I only have representation for the opposite and the adjacent, I really need the tangent function. So I'm going to say the tangent from my viewing point, which normally up to this point has been a degree measure, but now we don't know what that is, so we're going to represent that with that variable A. So the tangent from A should equal 15 over 20. And from here, if I need to solve for A is now protected inside this tangent function. So, to get it out of there, I need to do an inverse operation. Just like if I had 5 times x, the inverse operation would be division. Tangent has its own inverse function to cancel that out. So I'm going to say tangent inverse of this is going to cause that to cancel out. But what I do to one side, I also have to do to the other. So now I've canceled out tangent by using its inverse, and on the right-hand side, I have the tangent inverse of 15 over 20 as my answer. Now, just like before, I can have my calculator do that for me. Remember, make sure that you are in degree mode before you use any of these trig functions. And now that we're looking at the inverse, that's that -1 exponent that we see above tangent. So we're going to hit second tangent to pull up tangent inverse of 15 divided by 20. And since this is an angle, we typically round those to the nearest degree, but this tells us to round to the nearest tenth. So we're going to say this is approximately 36.9 degrees. Now with that being said, what I just found is this angle right here. So if I was asked to find B, or C rather, I could take 180 minus 90 minus the 39.6 and find the angle that's left over, which comes out to be 50.4. Or I could do another inverse trig function to find that missing angle. So for this particular question, they want you to solve all of the right triangles. So this is a good time to practice your trig skills. We are looking for missing side lengths and missing angles. However, given the fact that we are given an angle here, I can go ahead and subtract from 180 to get that angle measure. I can go ahead and subtract from 180 here as well to get 25. And last but not least, I can find this missing angle is 33. So it says find the length of KL. So I'm going to label that as X. And since I know all of the angles, I can pick my viewing point as M or K. It doesn't matter which one. Once we've decided where we're going to look from, we're going to label. And I have opposite and hypotenuse. The trig function that talks about opposite and hypotenuse is the sine function. So the sine from 40 should equal x over 8. To get x by itself, we multiply by 8. I know my 8's going to be a little hard to see here, so I'm going to change colors. And x is approximately whatever 8 times the sine of 40 is, which is approximately 5 Technically, if I'm solving this entire triangle, I would also need to solve for this side here, either now using Pythagorean theorem, now that I know I have 8 and 5.1, or by setting up another trig function. Either is totally valid, but for sake of time, we're only going to solve for KL. We're going to go ahead and move over here. So solving for NP, again, I can pick my viewing angle as 25 or 65, that's up to me. I'm typically going to just pick whatever they started with. So looking from Q, I have my opposite and my adjacent. So opposite and adjacent is the tangent function. So the tangent ratio from 65 degrees should be the opposite over the adjacent. To get x by itself, multiply by that denominator, and in my calculator, 10 times the tangent of 65 means that x is approximately 21.4. Last question here. Again, I would recommend you pause this video, try this on your own, and check back. We can pick either viewing angle that we want, but we're looking for RT. So if I look from 57, this is my opposite and hypotenuse. Opposite and hypotenuse is the sine ratio. So the sine from 57 should equal 15 over x. Remember that 15 over x really means 15 divided by x. So to get rid of that division, we multiply by that denominator. What we do to one side, we do to the other. So I now have x times the sine of 57 equals 15. Since x is being multiplied by something, I'm going to divide by that something. And what I do to one side, I have to do to the other. So in my calculator, I'm going to type 15 divided by the sine of 57. And I'm going to get about 17.9 for my x value. Couple of other pieces of information here. Now we're going to start looking for angles. So remember, when you look for an angle, you want to make sure you're using inverse trig at the end. So it says find angle A, and this is shifted for some reason. This find angle J should be over here. So if we're looking for angle A, we want to label that we have our opposite and our adjacent. If I look at SOHCAHTOA, my opposite and adjacent is the tangent function. So the tangent of A should equal 9 over 12. To get A out of the tangent function, I need to use its inverse. What I do to one side, I have to do to the other. So A is going to equal the tangent inverse of 9 over 12. So second tangent, to pull up the inverse, 9 divided by 12. And I find out that A is approximately, and again, we normally round this to the nearest degree if it's an angle. So let's say this is approximately 37 degrees. So now that I know that, if they ask me to find the other angle, all I would have to do is 180 minus 90 minus 37 tells me that this is approximately 53. For the next one, we're going to find angle D. So looking from D, we have our adjacent and our hypotenuse. That's the cosine ratio. So the cosine of D should equal the adjacent over the hypotenuse. To get rid of the cosine, cosine has its own inverse. So I take cosine inverse of both sides, so that D equals the cosine inverse of 3 over 9. So second cosine to pull up its inverse, 3 divided by 9. And I find out that D is approximately 71 degrees. So again, once I know D, if they ask me to find F, I can just subtract all of those angles from 180 to find out that F is about 19 degrees. I recommend that you try 15 on your own and then come back to check. So 15 is looking for J. I have my opposite and my hypotenuse. Opposite and hypotenuse tells me to use the sine function. So the sine from J should equal the 14 over 16. To get rid of sine, use its own inverse. What we do to one side, we do to the other. So J equals the sine inverse of 14 over 16. So second sine, 14 divided by 16. And we find that J is approximately 61 degrees, which means that my missing angle for G is 29. If they had asked me to solve these triangles, we would have to find that third side that we're missing. So we would either need to use a trig function or Pythagorean theorem to find those missing parts. Now you may notice that number 13 is secretly a Pythagorean triple, because this is 3 times 3, this is 4 times 3, so I know this would be 5 times 3, which is 15. However, the other pieces here that we have are not necessarily triples, so we would have to use Pythagorean theorem to find those missing sides. Or we could use a trig function. The last little bit here is going to be applications, and we're going to talk about that more in the following lesson. But how this is going to apply is we're going to see problems that have angles of elevation or depression. The big thing here, guys, is that your angle of elevation is always equal to your angle of depression. So basically, if we've got one person on top of this rock formation and one person on the beach, the angle at which they look down from their horizontal eye line is the same as the angle that they look up from their horizontal eye line. The reason for that, we've got parallel lines cut by a transversal. So therefore, our alternate interior angles are congruent. So from here, if you're skiing on a mountain with an altitude of 1,200 meters, your angle of depression is 21 degrees. So notice here, guys, that that angle of depression comes down from that horizontal line. So that 21 is in the top part of this. We also could bump that right here using our alternate interiors. And I know that if this is 1,200 meters, that vertical height, that this is as well. So I could move that over here if I wanted to. Then, if I'm looking for that x value from 21, this is my opposite. X is my hypotenuse. So if I have opposite and hypotenuse, that's the SO part of SOHCAHTOA. So I need the sine from 21 should equal the opposite over the hypotenuse. Since x is in the denominator, multiply to get it out. Since x is now being multiplied by something, we're going to divide by that something. And then this becomes a calculator problem where I can do 1,200 divided by the sine of 21. And I find out that x is approximately 3,349 feet. Or if we want to round to the nearest tenth, like we normally would here, we could say 3,348.5 feet. And I know that's kind of ugly. I'm going to rewrite that here. 3,348.5 feet. So trig is going to have lots of different application problems, and that's primarily what we're going to focus on tomorrow, is looking at these word problems and learning how to solve those. However, with the knowledge that you have now, you should be able to, as long as you can draw the picture, solve these types of questions. Please let me know if you have any questions or comments via email. Have a great day.